Good morning. My name is Matthias and I study biomedical science and German. I recently got back from studying abroad at the University of Konstanz in Germany, where I completed a research internship with the molecular toxicology group. Today, I'd like to tell you a little bit about the research project that I completed, and if you want to hear more about it, you can come to the IGP Summit, and I'll be there to talk about it. So, the title of my project in English is Investigating the Effects of DNA Damage Using C. elegans as a Model Organism. C. elegans is a roundworm, which you can see on the side here on this left-hand picture, this blue illuminated organism. It's a very small roundworm. It's a simple animal, about at its largest 1 millimeter in length. And it's a very useful model organism for molecular toxicology work because a large number of its DNA repair and damage response mechanisms are actually conserved across the entire animal kingdom, including in humans. So many of the pathways that an organism, even as simple as this worm, would use to respond to DNA damage, which of course can lead to cancer, are the same kind of mechanisms that are being used in our own bodies, probably on a daily basis as they encounter outside toxins and other molecules that could damage our DNA and lead to cancer in us. So this makes C. elegans a really useful model organism for this kind of work. And my project was to investigate how these responses to DNA damage are modulated by the life cycle phase that the worm is in. C. elegans has about 4 different life stages, and each one shows, greater development and different characteristics. So what I did was investigated how exactly that manifested in the DNA damage you could observe in the organism. So I did this by obviously culturing a horde of worms and then introducing a particular toxin, most often hydrogen peroxide, which would damage the DNA. And then I would use a technique called fluorometric analysis of DNA unwinding, which is a very large term, which is a very large name, so we can call it FADU instead. And this essentially allows you to run an assay using a pipetting robot that can take a time point at the beginning before too much DNA damage has occurred, and at the end, when more DNA damage has been enacted and more DNA has been unwound, and you can really see that effect more profoundly. You quantify that by using a fluorescent agent called cyber green, which binds to DNA damage. And then you can assess the extent of the damage with a plate reader, which will show you, again, that time point 1, time point final, and you can compare them to see how extensive the DNA damage was. And then over the course of the project, compare between the different life stages. So while the final conclusions of this project are yet to be published, the preliminary results we did see showed a negative correlation between the life stage of the worm and the extent of DNA damage incurred, which is to say, the older the worm, the less DNA damage they were susceptible to or that they incurred over the course of the protocol. This makes sense given that older worms see a larger amount of sort of protective outer skin, as well as possibly housing eggs that can mitigate some of that DNA damage that would otherwise go to the worm itself. So that is a broad overview of my project. If you would like to learn more about it, as I said earlier, I will be at the IGP Summit this November, and you can come by, find me at my poster, and I'd be more than happy to tell you all about it in English oder auf Deutsch. All right, thank you so much for your time, and I hope to see you there.